a.m. Pacific time. Thank you everyone for joining. Today we have the lead of our machine learning team, Vadim Markovtsev, joining us to talk about assisted code review with Source Lookout. So thank you, Vadim. Please take it away.
Hey everybody, I'm super happy to speak today. It's my first experience of talking on a source at Github, so I'm super happy again. I'm going to talk about our upcoming new product, Lookout, which is a platform for assisted code review. My presentation is divided into 4 parts. The first, we'll talk about the background of Lookout, why we decided to start the product, first of all, why assisted code review, what is assisted code review, and basically other options which we considered. The second part is about Lookout itself. I will talk about the architecture. I will show some diagrams of how it works, how it works with GitHub, and how it defines the extensible layer of analyzers at the bottom. The third part will be about software development kit, another let's say GitHub project, open source project which we have to help people create their own code review assistants on top of Lookout server. And the fourth part will be a live demonstration or a code lab, like 50-50. So I will show you how very easily, just given a few lines of code and very little efforts, everybody can create their own code review assistant, launch it, deploy it, and watch how it works on GitHub. And I'm starting with the origins. So I believe that many of you who joined work as software developers in teams, right? And if you work in a team, you should have a sort of internal set of standards to write source code. It can be expressed implicitly, for example, as something which your team lead knows, or it can be written explicitly as configuration files for linters, for example. It doesn't really matter how they are expressed, but what does matter is that so what does really matter is that it's kind of boring to follow those standards. I'm talking about source code style consistency, about formatting, about best practices, about following the rules which are enforced in your organization. And it's not really exciting. And if it's not exciting, we should do something with it, because programming should be an art and not the boring stuff. So here are a few examples of those boring issues which we have to solve every day. I use GitHub search as an approximation of how many times people had to fix specific topics. It's not really the best way of estimation, but this is just what I have. I don't have anything better in a constrained resources environment. If you search for using single quotes, this is a very typical example. Many languages don't distinguish between double quotes and single quotes. And some people want to have single quotes, some people want to use double quotes, although it doesn't really matter from the program point of view. And if you set up a linter, that's fine. If you don't, of course, if you care, you need to enforce this single or double quote rule by hand, which is not exciting. So 1,000 issues contain this use single quotes here string, which signals that really many people have to deal with this problem. Another example is indentation. You can indent with spaces, or you can indent with tabs. And again, it doesn't really matter from program point of view. It will still be interpreted or compiled anyway. but it should be uniform across your project. Otherwise, it will be hard to read, it will be hard to format, so on and so forth. So 10,000 issues contain indent with spaces stream. So it's quite considerable. Another example is specific to Python. Python has a feature which is called list comprehension. It's an alternative to writing a plain for loop. And usually it's a good idea to have a list comprehension if your for loop is small and can be expressed as a very neat one-line syntactic sugar. So 2,600 issues are devoted to using a list comprehension instead of a for loop. So you can treat it as a best practice or a micro optimization or whatever you call it. But at the end of the day, this is something we should just enforce because you are used to that, because your project uses list comprehensions, and usually it's considered a good practice to use list comprehensions. Splitting functions is also another example. Imagine that you have a huge function, it does many things, and if your function is big enough, you should consider splitting it into smaller functions. It's a typical refactoring, everybody knows it, and although everybody knows it, a few people do it during initial pull request submission. So 8,000 issues, I checked them manually, most of them are actually pull requests. So people really ask other people to split functions because they are big and they should be refactored. Renaming is a very, very famous problem. There are two very complex things in programming. One is naming and the other is cache invalidation, right? So naming is hard. Also, it's very hard if you're not used to contribute to a specific project. If you are a first-time contributor or you just did a few pull requests before, you don't know everything about the project, you don't know all the names, so it's hard for you to name things properly. You just don't have enough knowledge. And maintainers usually recommend you to rename some specific classes or functions because this is the way they should be named in the project's code. So 9,000 times people ask to rename an entity, which is also huge. Commenting is also something which we should do, also something which doesn't really influence the program behavior, but you should do it to have a good style and make the code readable. 48,000 times people asked to add a comment. For sure, some of them are related to issues. For example, please add a comment to this issue is actually not a pull request, but there are many pull requests inside where people ask to add a comment for some tricky behavioral function just to make sure that everything is correct and future coders and programmers will be able to comprehend this function. And my favorite one is fix a typo. When you write source code, you often are in a hurry and you can misspell things, especially if you are not native speaker. I saw it many times. People from all over the world just don't know how to write very complex long English names properly, so they confuse them. And 910,000 commits contain fix a typo message, which is like, it's incredible. It's incredibly huge. I cannot even imagine this big number. And all those comments are actually just fixing the typos. Not really that much important, but would be good to have. So it's unimaginable. You may know about Hacktoberfest. Last year was the 5th session, and the #1 type of pull request we received at Sourced was actually fixing typos in our source code or documentation. I guess if we create an AI to fix all those typos, next year people will just not receive t-shirts because they will have nothing to fix, unfortunately. Okay, so to summarize, many efforts which we spend on ensuring the consistency of our source code style is boring. And if it's boring, we can do something with it. If it's boring, you know how to do it, it's predictable, there are no surprises, there can be an algorithm which you just can follow and fix things. And this means that you can automate it, right? For sure, automatable doesn't mean unattended, because some sorts of things really require human intervention. If you, for example, want to have a good name, it is not going to be unattended, never. It should always ask for other people's opinion for maintainer. It's okay to provide a few options which you can choose from, but for sure, AI should not really set the correct variant and just push it or comment it. All right, so now we kind of know what we should do. We should reduce the amount of these boring efforts which we spend on maintaining the consistency of our source code, for ensuring the correct formatting, or following these micro best practices, or doing any other stuff of any other type of rules compliance. So then the next question is when we should assist people with these boring efforts. And we have a few options. The first is to suggest fixes and improvements while you type. It basically means when you are using an IDE, VS Code or IntelliJ, it doesn't really matter. Another option is to use continuous integration and have a specific rule which we will check for style, and also will try to fix something which is fixable. The next option is to plug into code review process. Especially it's doable for GitHub. GitHub has very nice interface for making pull requests, and you can comment in those pull requests. So you can add comments to a pull request, which will try to suggest you fixes for your code style. And the final option is to just run something periodically from time to time, which will take all your source code, run it through a set of fixers, and somehow will present you those fixes on a regular basis. So I will talk in a bit more detail for each of the options. If you consider an IDE, the good thing about IDE is that it can provide you an instant feedback. If you suggest something to people, they immediately see it and they can reject it, close it, or accept it. So it's a very good opportunity for reinforcement learning when you learn while you do something. At the same time, it's also a drawback because instant feedback means you really have little time to think, to run your potentially sophisticated machine learning algorithms and suggest fixes. Also, IDEs provide you with rich information about the source code which you analyze. Because they have to do it. They already have IntelliSense, they already parse source code, probably they know how to compile it, to build it. So it's a very rich source of information. Also, it's robust because IDEs parse source code robustly and don't break if something is not correctly expressed from the syntax point of view. And also, IDEs have a rich user interface. You can display your suggestions and fixes in any way you want. You can diverge for different types. So it's really powerful. And also speaking about drawbacks, IDEs Unfortunately, it's not as there is no such a thing as a single IDE. You have many IDEs, and there is no standard for coding. Some people use VS Code, some people use IntelliJ, some Eclipse, and some code in Vim. So it's really hard to cover all the groups of people if you want to have a uniform suggestion. Also, there are different programming languages, obviously, and the way usually IDEs work with those programming languages is unique. If you install a PyCharm has its own unique way of dealing with Python. If you install Golang, Golang will treat Go code again in a unique, separate way. So if you multiply the number of languages by the number of IDEs, you will have a huge number of all possible implementations which you have to provide. This is very challenging. If we consider CI, it's a part of our workflow. We cannot bypass it, which is great. At the same time, there is no UI. The only way for you to report problems in continuous integration is to print them in the log. And this is not something very exciting. And also, it's an open question how you can fix during code review, because reporting is one problem, but fixing is another, and we want to do both because we assist. CI provides you more time to run your analyzers for source code, for sure. If your tests run for a few minutes, it's okay to spend another minute for some code intelligence. That's good. Also, you cannot really be wrong in your assumptions in CI, because CI is a binary outcome. It's either a green tick or it's a red cross, and you cannot really do partially passing the CI. So if you apply something related to machine learning always makes mistakes. For sure, we try to reduce them as much as possible, but we still always have mistakes, and CI will break because of them, and people will be annoyed with that. So it's very tricky because of that. And also, it's a longer feedback loop, because for sure you can run your CI locally, but that's not what people usually do. Usually you create a PR and wait for Travis to build it, or Upwear, or any other CI system you use, and then you observe the results and fix your code accordingly if something is wrong. You don't really run everything on your laptop, because potentially your test suite is huge and you don't want to spend your laptop power on this. Instead, you want to, I don't know, take another task to solve. So PR reviews are also a part of your workflow. Hopefully, I hope you do code reviews, don't you guys? At the same time, it's also a longer feedback loop compared to an IDE. So the only way for you to see suggestions is to create a PR or update a PR and see the comments in the user interface. And speaking about user interface, yes, you have one. Speaking about GitHub, you have a very nice way to suggest changes. They recently added this feature, which we really like. So we can use it and just suggest the fixed lines of source code in the places we want. Also, you have more time to run, because while your CI is running during APR, you have some time to run other things. So CI is a bottleneck, usually not linters or other steps. So you can take much time and run your intelligent assistant and wait until it finishes. At the same time, you should not be wrong. This is very important. Well, there is a paper by Google engineers, I think from last year, where they described how they try to automate code reviews and make them better. and provide this code review intelligence. And their conclusion was that you should make as few mistakes as possible, otherwise you lose the trust and nobody uses your tool. So if you make more errors in your assistance as you should, you just lose attention and nobody uses your product. So the final option which we considered is just running everything periodically. And apart from having much time to run everything, there are many drawbacks to this approach. It's outside of the workflow. The same Google paper says that this way of doing things is very bad. Google tried it and it didn't work at all. There is no UI, obviously. I mean, out of the box, for sure you can create one, but it's an additional layer of work. And the feedback loop is the longest one. If you run it every day, your feedback goes to you every day, and your problems tend to accumulate, and then you need to fix 1,000 problems, and then it's very bad. Okay, so this table shows a brief comparison of all the approaches. And I would say that IDE is probably the best option, but it's not that good if you don't own your own IDE, because you have to support all of them, which, as I already said, is very challenging. So instead, we decided to focus on pull requests and provide assistance during code reviews. Yeah. If we consider code reviews in particular, there is a very nice blog post which you see on the slide from Codacy. And well, apart from a funny GIF picture here, there is an interesting conclusion that 20% of code review comments are about style and best practices. In my opinion, it's a bit optimistic. I think it's even more. If you look at the way this number was calculated, it was roughly the same as I did with GitHub search. So they took a few regular expressions and just looked for those regular expressions in pull requests and grouped them together. So it's a lot of manual work. I think it's more than 20%, but already 20% is a huge number, which should be somehow automated, because we should focus on interesting things and not on boring things. So I'm passing over to Lookout, which is our effort to create a platform for assisted code review, which will allow everybody to create assistance and, you know, finally automate this boring stuff. So our goals is be language agnostic in both implementation and analysis. This is our, let's say, core key point. We don't want to implement our assistance for each language independently. Although, of course, the world is not ideal, and even if we use a universal abstract syntax tree and work with all languages, express it in the same format, you still have to take into account the special features of every language. So there is still you still have some work to do, unfortunately. But we try to reduce it as much as possible with XPath, with all these UST wrappers, with high-level functions which work with USTs, with traversal algorithms. So it should be easier than, you know, starting each language from scratch, for sure. And we want to allow create assistance, which we call analyzers in this context. We want to allow creating them in any language people want. We basically work through RPC, and if your language is supported in gRPC, you can create an assistant. No problem with that. Okay, and one important thing which I missed is that it only works with GitHub as of now, and it's tightly coupled to this Git. So it will never work with Mercurial or SVN or other version control systems. This is the brief diagram which shows the architecture of Lookout. So you have Lookout server in the center. It talks to GitHub through GitHub API, and it receives events from GitHub, and it sends comments to GitHub. And each analyzer is an independent application which you run on your side, or on our side. It's not really decided yet. I don't know about the plans. And they talk to Lookout servers through gRPC. And as I said, you can use any language which gRPC supports. That's not a problem. So we support two types of events in Lookout server. I'll start with push event. So it happens when you update a reference in your Git repository and push it to GitHub. So we receive a notification from GitHub. Then Lookout server notifies analyzers that there is a repository update, and probably they should do something with it. And analyzers send data requests back to Lookout server. We decided to do it this way because we don't know beforehand what each analyzer wants. Will it be just raw source code, or UESTs, or both, or maybe something else in the future? We don't know it. So we decided to create an API in Lookout server which will allow you to ask for UEST of a specific file, or raw contents of a specific file, or any other information which you need. So analyzer asks for new files to Lookout server, and Lookout server proxies these requests to Babelfish, or takes them directly from the Git database which it maintains. It caches Git repositories on its side. Once it gets UESTs and raw contents, or one of those two if it's required, it responds to analyzers and gives them this information. Then something happens, machine learning or some algorithm which doesn't really need to train, maybe it's just some simple statistical approach, and they just notify Lookout server that everything is fine and they are finished. And push event processing is finished at this point. The second type of event is a PR event, when you create a pull request and you want to actually analyze the incoming submission and report any violations and try to fix them. In this case, all the previous steps are the same up to the point that analyzer returns the list of comments to the Lookout server. And when Lookout server receives the list of comments, they are literally comments. They are bound to a specific file, to a specific line, and they should be visualized in GitHub user interface. Lookout server sends those comments to GitHub, and they're shown to the user. That's it. So doesn't look very complicated, right? Well, for sure, it's a bit more complex than that. And if you go to this link, you can read very nice documentation our applications team has written on Lookout, and you will be able to pass through tutorials, through examples, read more about the architecture, the implementation, and so on and so forth. And I'm passing over to software development kit. So Lookout server is awesome to have, but what we really want to do is to build an ecosystem of analyzers which talk to Lookout server. Some of them can be ours, some of them can belong to community. And it's impossible to achieve without a good software development kit. And actually we have two. And this diagram shows the relations between our two SDKs. The first one is just a lookout SDK, and its purpose is to provide a low-level API to interested parties. Source lookout is based on lookout SDK because we have a single source of gRPC definitions. And the second SDK, lookout SDK ML, SDK for machine learning, although it's not really bound to machine learning, also uses lookout SDK for low-level API to talk to lookout. So this slide basically repeats what I just said. There is an important addition is that currently Lookout SDK has pre-generated APIs for Go and Python. It's not really difficult to turn a protobuf, gRPC definition to a wrapper in any language. It's just we decided that we will pre-generate for Python and Go. If you love a language and you want to add it, feel free to create a pull request. We will be happy to merge it. Our goal is to support as many languages as possible. So the second SDK, Lookout SDK ML, has been written by machine learning team, although it's not really, dependent on any specifics of machine learning. It provides a high-level Python API, and I will show it on the next slides. It's really high-level. It just forces you to create two functions, and it's very easy to use. And it also makes an assumption that your analyzers are stateful. And this is important because in the general case, you can just ignore the push event and just do something at analysis time. However, if you want to do something at the push time, you're going to save your state to use it at analysis time. And maintaining those states can be tricky. You have to do something with those states. So SDK-ML provides you a way to don't really care about how to deal with your state, and everything is abstracted. Finally, SDK-ML is integrated with the Source.ml ecosystem, which means that you can leverage the full power of research we've done at machine learning team with Source.it. We've been doing it for 2 years, so we have quite a few achievements in this area. You don't really have to, and I don't think we really depend on Source.ml in SDK-ML, but it's on at your fingertips. Okay, so as a rule of thumb, if you know Python, you should use SDK-ML because it's very high level, it's very easy to use. If you don't know Python or don't need to use Python, you should use the regular SDK and implement many things from scratch. For now, for sure, we will improve SDK in the future and add more high-level abstractions to SDK repository itself. So this slide shows you what is a high-level API in SDK-ML. You have two entities. You have analyzer class and analyzer model class. Analyzer model is your state, and analyzer is a base class which abstracts all the rest of the stuff, which you don't need to care about. Train function is triggered when you have a push event, and it produces a state. And analyze function is triggered when you need to analyze something, and it produces a list of comments. So it doesn't really look so complicated. The train function receives a reference pointer to the repository state. It's basically a Git hash with a URL. Also, it consumes a configuration which you can specify beforehand upon launching Lookout server. It's not really needed, obligatory, but you can use it for global configuration. It has a data service argument, which is your channel to use to get data from Lookout server, USTs or files or whatever. And if you use decorator, you also have a files argument, which give you the list of files which are contained in the repo, and those files have the UST and the raw source code inside. And the analyze function is very similar. You have to reference pointer, the previous original state where you started your pull request, and the head state, the head of your pull request. You have a data service channel again, and you have a list of changes. Each change is a pair of files, the same terminology as we had for train. So you have USTs before, USTs after, and raw file contents before, raw file contents after. And behind the scenes, Lookout SDK takes care of connection pooling and dealing with threading, and it works with gRPC servers and clients. I'm not sure about other languages, but for Python, gRPC API is really low level, and you would always like to abstract from it. It maintains a database of trained models. It takes care of caching them. It takes care of logging, of metrics collection, and other things. So it does quite a few heavy lifting so that you can concentrate on what's important. All right. So I've got roughly 10 minutes, and I can pass over to a demonstration of Lookout in action. So we are going to design and run a typo correction. So a typical typo correction is a general purpose one, which works on top of a dictionary, and that dictionary is taken from random place and is really tailored for programming. And this all leads to a situation when you have, for example, a class spec file, and you get a very stupid suggestion when you review your source code. So back file is a general purpose term from journalism, but it's not applicable to programming. And that's what 95% of all spelling checkers which I have ever seen use, unfortunately. So instead, we would like to not fix a pack file identifier if we already have some source code which has pack file in identifiers. So imagine that we used to have a function read pack file, and then we add class pack file. Our code review assistant should be smart enough to understand that, okay, we already have pack file, so we should not really suggest anything. Yeah, exactly. So final thing. If you, however, do a real typo and misspell pack file, just miss out I, and it reads as packful, this one should be corrected. And also it should take into account the pack file sub-identifier which you already have in your existing code base. Okay. So our steps will be installing Lookout SDK-ML and autocorrect package for Python. It's a general purpose package to do auto correction of misspellings. We will write a file with typos. It's only 80 lines long. It's really tiny. We fork some repository, create a pull request, generate a GitHub personal access token to be able to use GitHub API and enable Lookout to create a comment from your user, and finally run it. So actually, I'm not going to do these steps from scratch. Instead, I will reuse the existing file which I've already written. Here it goes. You can access it by the link. Probably it's tiny. It's source Lookout SDK-ML, blog master Lookout core examples typos py. It's 87 lines, and it's our analyzer which we will launch, which we will deploy and run. It defines a very small state. Our state will be basically the list of identifiers which we encountered in the code base, so that we can do a better job at autocorrection. So we just have a set of names and we save it and load it as we go. Our analyzer, as I promised, contains two functions, and I'd better show it in VS Code because VS Code can fold. Yes, it can fold source code, and also it demonstrates how the typical spelling corrector does a terrible job. For example, it says that Babelfish is unknown or UST is unknown, although all my existing source code uses Babelfish and UST many times. And it's not that hard to infer that I'm using it all the time, so it's not really a misspelling. Anyway, so the analyze function, maybe I should start with the train because train is simpler. Okay, I'm using UST IDs to back, and this one is taken from source.xml. We've written quite a lot of source code in the past to work with identifiers, and I'm reusing it here. So UST IDs to back basically is a class which is able to take a UST, extract all identifiers, split them, and output the set of them. So this is all it does. Also, we say that we want to parse tokens, and we don't want to stem them to normalize, basically in NLP sense. We don't want this NLP stuff, so we set a rather big threshold. So for each file which we receive, we take the UST from that file, apply this class to extract identifiers, and add them to our model with identifiers set. Okay, and now the analyze. In case of analyze, we do a few tricks with autocorrect. So to cut the long story short, autocorrect just maintains a list of known items in the vocabulary, and then if you have a string, it measures the distance to each of the strings in the vocabulary. If there is a match, it shows the matched word. If there is no match, it takes the nearest word and suggests it. So we have the list of names from our state. We iterate for each identifier in our state and add it to the list of known words for the autocorrect Python package. Then we iterate through changes. We find the line numbers which are changed. Find new lines is a routine which is implemented in Lookout SDK-ML. We use it in many other places and other analyzers. It's generic, so it just takes the base file, the new file, compares them, and outputs the list of line numbers which are new. Also, you can find the numbers which are deleted. We don't need it here, we just need the numbers which are changed. So given the new lines, you run a super simple UST XPath query. You just extract all identifiers from the new UST. For each node, you check that the start position is defined. Some of UST nodes do not have a position assigned. And if it has a position, you check that the line number is in the set of line numbers which are changing. Then we split the token value using the parser which we take from source.ml here. We try to fix the spelling in each part of identifier, and if the fixed variant is not the same as the original one, we add it to our list of suggestions. So probably I should say something about those token parts. The thing is, usually your identifier is like this, so it contains two parts, known and words. and you would like to split it before autocorrection because otherwise it makes no sense. So you have to parse it. And particularly, we had a neural parser of tokens in machine learning team. We even wrote a paper about it. In this case, for simplicity, we don't use it and just apply a regular heuristic-based token splitter. And this part just basically formats the gRPC comment structure so that it can be sent to GitHub. So we create a comment, we say that our file is path which we have in the change. We do some text formatting, and then we say that our line number is as we have. We are super confident, 100% confident. For sure, it's over simplified. In the real typo fixer, we would trade this confidence somehow. We append it, and then we return. So as easy as that, and it's only 87 lines. So now we are going to launch it. And to launch it, I will use the command for launching. Code package. If you install the Lookout SDK ML Python package, you will have this analyzer command. It will allow you to run an analyzer locally or to package and deploy it and do other things. In this case, we want to take our typos analyzer, package it inside a Docker container, then run everything in Docker Compose and actually generate the comments in the repo. So I write typos there because I am in a directory with two files. This is unrelated, so I just use this single file. And if you remove the .py extension, it will be typos. So this is why I have here package typos. So it can be any file, and I've just shown you the file which is real. The next step will be to fork a repo and create a few pull requests. I've already done it. I cloned GoGit, and GoGit is our Go implementation, Git implementation in pure Go. It's very awesome. You should check it out if you love coding in Go. So I cloned it and create a few sample pull requests. The first one adds type repository pukful struct at the bottom of repository.go at the root level. So obviously we have a typo here. It should be repository and pack file. I'm confident that it will be fixed properly because pack file is a Git terminology, and we already have pack file in many other places in Go Git source code. The second pull request is a normal one. Well, for sure it's not a normal one, but at least there are no typos. I write io-util pack file, and I assure you, if you apply a generic typo corrector, it will say that io-util is not really correctly spelled, and also pack file should be replaced with back file. So these are our two pull requests, and let's see how we perform on them. So I'm going to run this command. So you may notice that I also specify my username and also my personal GitHub access token. If you Google it, it's very well described in official GitHub documentation. So I'm not going to go into detail here how to get it. Also, I specify the repository name which we will inspect in In this case, it will be, well, I cannot see my mouse. Okay, it should be vmarkovsef/gogit. This is the name of my repo which I forked. And this is the working directory which we will use to assemble everything, to generate configuration files, to build Docker containers, so on and so forth. So I will run it. We will wait maybe 1 or 2 minutes, and we will see the results as GitHub comments, hopefully. Let's see. So it tries to import the typos analyzer. It analyzed all the Python dependencies. It found out that it depends on autocorrect, so it should include autocorrect in the Docker container. All these dependencies are automatically inferred, and you don't really have to specify a requirements file or any other way, to define your dependencies. Everything should be done automatically and without your intervention. So it wrote some configuration files, and now I just ask you to continue running with Docker build and Docker compose, and you say yes. It built the Docker image. For sure, it was so fast because I've already built it, and it uses the cached layers. It initialized the database. It launched the analyzer. It launched the lookout server. And it failed to dial this IP and port because it wasn't enough time for it to boot. Okay, a failure launch. Let me just launch it another time. I think it will work. It works this way because, as you see, my laptop struggles with all the video streams and the timings are different. And for, again, simplistic purposes, everything is organized as sleep, and sleep 5 is obviously not enough if you have a huge resource consumption. So maybe I shouldn't really repeat everything, but I just repeat this command in my working directory. So I go to tmp package. Let me edit the configuration and add more time to wait. So it's sleep 10, let it be sleep 15. Now I repeat this command. It takes some time to load the autocorrect Python package because it contains a huge list of existing words in the vocabulary. It's a bzip2 archived file, and it tries to decompress it. And Python can be sometimes slow at this type of load. Okay, so what do we have? Okay, nothing worked. I can tell you why, because the previous time we launched Lookout, it found out about 2 review requests, and it marked them in the database as handled because there were no analyzers to process. So what we should do is we should remove the image. So now we dropped the Postgres database, and now we just repeat it. So you see Postgres database has initialized again. I think it should be fine this time. All right. So now you see that it received the review events by inferring them on your repository. And now it uses Babelfish to extract UESTs from GoGit source code. It usually takes less than a minute, but since my laptop struggles really hard with the video stream, maybe it will take a little bit longer. So while it's running, maybe I can answer a few questions.
So feel free to post questions in the chat. You have one.
So you see, it finished parsing the original source code. It found out that there are 2,000 identifiers in GoGit. Then it launched the analysis. All right. So let's see if we have something. So as you see, we have a comment generated for the pull request with a sample typo. It says that repository pack file contains the part repository, which should be fixed to repository. And the second part, pack file, should be changed to pack file. For sure, if I did it in a proper way, I would use a GitHub suggested change. But if you want to generate the source code line with the fix, you need to assemble the correct identifier from the parts which you fix. Also ensure the same naming style is preserved. So those 87 lines will be, let's say, 150 lines. And I'm demonstrating, so I don't really want to overcomplicate this example. Also, we are developing a proper typo analyzer, which is based on identifier embeddings, which should be even better than this one. So let's see on the second pull request. And as we see, nothing is generated, so we don't have any fixes, and this means that it works and it doesn't generate spurious spelling corrections. Okay, so to summarize my presentation, we decided to create a product for assisted code review, which we named Lookout, which is, in my opinion, a great platform for that type of work. We ensure that creating new analyzers is easy and fun. Much can be improved in the future. For example, those timings are annoying, and I should really learn Docker Compose to avoid those sleeps. Anyway, as you see, one simple command, if everything worked from scratch, it would be one simple command. In our case, it was 3. Anyway, it should be one simple command to run your analyzer, which is deployed, and you see it instantly on GitHub. This is how it should work. This is all about my presentation. Here are the links on the left. Sourced Lookout repo on GitHub. Sourced Lookout SDKML repo on GitHub. We write blog posts, articles. We have a Medium account. You should subscribe to our newsletter. And we have Twitter account, Sourced Tech. This is my personal one.
Hey, Vadim, we have a question from Henry. The first one is, do you plan on building an integrated tool like codebase to run Lookout on GitHub projects?
Sorry, can you repeat this?
Do you plan on building an integrated tool to run Lookout on GitHub projects?
Yes, I guess, but I'm not probably the right person to answer this type of question because I'm not a product So I can tell you anything, but it will not be an official opinion.
Yeah, the short answer is it's on the roadmap. The next question, do you have examples on method and class naming suggestions?
For now, it's only 2 examples. The first one is even more simple than this one. It will just output the number of UEST nodes which are changed. We really want to work in this direction. For now, we have a style analyzer project which machine learning team is doing for fixing any source code style issues. Will it be formatting or naming? So I guess we should include it to provide better naming, as I showed in the beginning, to suggest you to split functions or add comments or do other things.
Awesome. Anyone else? We're almost out of time, but come on, one more question for the. Well, looks like that's it. Vadim, thank you very much. We'll be publishing this recording very soon. And in the meantime, we hope to see you on the community Slack and also like yeah, the newsletter. You'll get information about upcoming Lookout release. So thank you very much, and have a good rest of the day.
Thank you for attending. Bye, everybody.